Yeah, there's not much sun coming in anymore. It is already late afternoon. Look at the sun. Sun is almost down. Guess what? Happens every afternoon. Guys, welcome back to the Off-Grid Garage here. Not so sunny Australia anymore. In today's video, we want to have a look at the Gobel Power battery monitoring system for Home Assistant. Yeah, Gobel Power is one of the few manufacturers which actually has their own Home Assistant integration. And they also have a battery monitoring kit, so a piece of hardware which connects your BMS to the network and to Home Assistant. And this works with the PACE BMS, the older and the brand new one, and also with the JK inverter BMS. Yeah, and in today's video I want to show you how this all works. So you can see here the brand new Gobel Power BMS. We've got a Waveshare. We've got a Waveshare RS485 to Ethernet server. And what this thing does is basically put all the data of your BMS onto your network. And Home Assistant on the other side reads the information from your network and displays a ton of information and data of your BMS and your batteries. And this version here is an RS485 to Ethernet server. You can also get them as Wi-Fi and USB gateways. And I know there are a ton of other projects out there which basically do the same. They read the information from the BMS and connect with Home Assistant. They're using ESP32 chips and usually connect via RS232 or RS485 to your BMS, collect all the data and send this then to Home Assistant. Yeah, this gateway basically has a power connection down here, 6 to 36 volts. Ethernet RJ45 connect to your network, and here at the top we've got the TX and RX for your RS232 connection, an earth and a ground connection, and another one which I don't know what it actually does. You can unplug all these terminals, and the gateway also comes with a DIN rail mount, so you can nicely put it in a little box. No wires hanging around, so very clean installation. And the kit also comes with a buck converter. 60 volts down to 12 volts, 2 amps. So you can connect this gateway directly to your battery with the help of this buck converter. And then there's also this connection cable. It's an RJ11, which connects to the RS232 port of the BMS. And then there's also a meter of shielded cable included. And you basically connect the RX and TX and ground from your BMS to the gateway. And the good thing with these Waveshare Modbus gateways is everything is completely isolated. Data RS232 completely isolated, power supply completely isolated. So this is exactly how we should connect anything to the BMS. If you have several batteries and BMS in parallel, you need only one of these battery monitoring kits. One is enough, connect this to the master and it reads everything. And here on the Gobel Power website, you can see the different variants of the Gobel Power BMS Monitoring IoT Kit. That's the official naming. The price is 41 Australian dollars, so that's probably like 25 euros or so. So it comes with a gateway, the cable to connect to the BMS, and a piece of shielded cable as well, but you can use your own as well then. And here next to it, you can see the RS232 to Wi-Fi Modbus gateway. Yeah, it's a bit strange that they don't show the price here anymore. They give you a bit of an example for a dashboard here. You can see all the battery cells. Then we will have a look in Home Assistant then later ourselves. This is just an example what they give you here. But I wanted to show you here the user manual for that, which is really, really good. It's very, very detailed. It walks you through how to set up the MQTT broker on Home Assistant if you haven't this already. And then how to connect the RS232 to USB, to Wi-Fi or to Ethernet, depending on what kind of gateway you have. How to configure each of them. And then you can also use their Home Assistant dashboard generator to fully automatically generate a dashboard to get you started in Home Assistant. So pretty cool. Let's have a look at the connection RS232 to Ethernet. This is what we have right now. You can see here the Gobel Power BMS RS232. Yep, this is this piece of cable which plugs in, and then you use pin 345. Then you connect red to RX, blue to TX, and green is your ground. This all goes to your Modbus gateway. And from there on, this device sends all the data onto your network. But let me wire everything up here so you can see the full setup, and then I'll show you how to program this one. You won't believe how easy it is. So there you can see the full setup. There's your gateway connected via this cable to this adapter, and this plugs into the RS232 port of the BMS. And you just follow the instructions and have the red, blue and green cable connected in the right order. And the same here on the other side, connected to RX, TX and ground. And here on the other side of the gateway, you have the Ethernet cable going to your router or switch, and positive and negative going into the gateway. And this is what you can use the buck converter for. You can connect it to your battery directly and then feed it from your 48 volt system, and it converts it down to 12 volt to run this gateway. But I'm just using the power supply now. So I've set mine here to 20 volts or something. You can see it pulls only 12 milliamps. So it doesn't use much power at all. Red light is on. There's also a link light already. So the super easiest way to set up this device is if you download a software called VirCom. This is also linked on the Gobel Power website. And once you start this software, you just click on device and it scans your network for all the Waveshare gateways you have installed. So here in my case, it finds only this one. You double click on it and you give this device a network address in your network range. I'm using 10.0.0 and I give this device the IP address number 2. The port, you can select whatever you like. Default port is 9999. So the only other thing you need to check here is that your network is correctly masked. Usually it is 255, 255, 2550. But if you have configured a larger network, you may have to change this here as well. The gateway I have deliberately not changed. So in this case, this device cannot talk to the outside world. But it is not necessary. It runs locally in your network. And then you set the baud rate for the new Gobel Power BMS for RS232 to 115/200. If you use one of the older Gobel Power BMSs or PACE BMSs, you set this one here to 9600. And these are the only few parameters you need to change. Everything else you don't need to touch at all. After you set your IP address, the port, check on your network mask, and set the baud rate correctly depending on your BMS, you click on Restart Device, and this saves all the parameters now. So we have now set the IP address 10.0.0.2. So if we go into a browser and type in 10.0.0.2, in theory, we should be able, there it is already, RS232 to Ethernet. So it's now on my local network already. I type in the password admin, and you're in the configuration as well. You can see the exactly same parameters as we have just seen in the VirCom software. And there's nothing you need to change here. This just proves your Modbus gateway is correctly configured. It is now on your network, it is accessible, and this is all you need to do with this device. You're completely set up now. Alright, so we don't need the VirCom software anymore. We just close this here. I've totally forgotten to show you actually step number 1, which is downloading and installing the Home Assistant integration for the PACE and also JK inverter BMS. So we click on this one. So the first link brings you to the Home Assistant official website. So you can download Home Assistant there for free and install this on pretty much any hardware. Once you have done this, you go to the add-on GitHub page. And this is the official Gobel Power Battery Home Assistant add-on. You scroll a bit further down, documentation again, and there's the button for the installation. You just click on this button and it will install the integration for you automatically in your Home Assistant. So once this is done, you click on the icon down here and go to apps. And then you can see the Gobel Power Monitor add-on is already installed here. So we open this one up. So up here you have the info, the configuration and the logs. We go to configuration, because we need to tell the Home Assistant integration now what IP address our Modbus gateway has. So it can connect and get all the information. So here in the top section, there is the general connection to MQTT. I assume this is already set up in your Home Assistant because you have used MQTT for other things already. So you basically have to put in your MQTT port, the username and password in. And further down here, you can set up a device name, manufacturer, and also the model. So let's change this one to PACE BMS because this is what it has. 16 up to 16 batteries parallel. And then down here you specify Ethernet, RS232 we are using, and we've got the PACE low voltage BMS here. I will also show you the setup for the JK-PB inverter BMS later on. And then just below, you type in the IP address of your Modbus gateway we have just configured. 9999 is the default port. And down here, you change this one to 115.200 for the new Gobel Power BMS. The poll interval, you can change this one between 1 second and whatever frequency you want to have. So I've set my one up here to 10 seconds. And further down here, the debug is usually on 0, so you don't get spammed in your log file. And this one, I don't know what it is. It sits on 0. I've never touched it. So once you have configured everything, you click on Save. And we go back to Info. And down here, we can start the add-on. So if we now have a look in the log files, we can see the output here of the log file. You can see here the info, Ethernet, baud rate, Ethernet 10002, and it also connects to your MQTT successfully. And then it doesn't do anything because I have not turned on the BMS yet. All right. Okay, we just do a restart here and go back into the log file. And we can see already data coming in. So if you look closely, you can read the data. Cell number 16, cell voltage warnings, normal, normal, normal. Everything is normal for all the cells. Yeah, here, cell voltages. Here they are. 3266, 3281, and so forth. All the 16 cells are here. The temperatures are here. Everything is here. And it should update this information here every 10 seconds because this is what we have set. There it comes. So this is all now available already in Home Assistant. And we don't need to do anything more in this device. You can set it to start and reboot, which I would recommend, and also the watchdog. So if it crashes, it automatically restarts. And also if you want, you can turn off this debug and just set this one here to 0 so you don't see all the data in the log file because the log files are getting pretty large. But for the beginning, you can turn it on and see how all the data comes in, ensuring everything is working. And then we go back again. We go into devices and services. We go under MQTT. And here we can see the Gobel Power monitor. The Gobel monitor, that's what we have called it. And we have 118 entities for this one BMS. For one BMS, 118. So let's see what we have. Pack number 1 here, cell voltage number 1, cell voltage number 2, and so on. We got the cell voltage difference, the maximum cell voltage, which cell it is, the minimum cell voltage, which cell it is, and so on. All the warnings are here. They are all on normal at the moment. So everything is being transferred to Home Assistant now. A ton of information. You can see I'm scrolling and scrolling. I'm just halfway through. So much information in here. Here are the temperatures, the power coming into the BMS or going out. Yeah, remaining capacity, it's another 1.25 ampere hours for this 5 ampere hour test battery we are connected to. We've got a state of charge here of 25% and more warnings here. High current, high temperature, high everything. A ton of information. Boom! Total voltage 52.47. And of course you can click on each of the entities and get the graph for it and can do all kind of automations now. You can create your own dashboards and monitoring everything. And if there is something going on, one of the warnings coming on, the cell gets too high, temperature gets too high, current is too high, state of charge goes too low, BMS triggers a warning, goes into Home Assistant, turns on a charger or turns off load, turns on a fan, or simply sends you a notification on your mobile phone then. So possibilities are endless now. Yeah, that is pretty crazy. Okay, let's connect another BMS or maybe 2 BMS and see how this all looks like in Home Assistant then. All right, so let's go back into MQTT. So you can see the Gobel Power monitor. That's the master BMS we have connected, and now I'm plugging in another one. We are RS485, yeah, the usual normal power layering. All these dip switches are on 0 here, and the other Gobel Power BMS is in this battery there. It sits on 0 as well, so they should negotiate the actual address automatically now and should show all the data here in Home Assistant. So let's have a look. So and now if you have a look at MQTT, now we can see the Gobel Power Monitor BMS here again with 201 entities, from 118 to 201 entities. So let's have a look what's going on. So we still start with PAC 01. And if we scroll a bit further down, a bit more, this is all still PAC 01. We then see PAC 02 here all of a sudden, yeah? Cell voltage of the cell number 1. And this is all PAC number 2. So you're getting the exact same information for PAC number 1 and PAC number 2. All in MQTT. This is all PAC number 2. And if you go all the way down, you have the aggregated data coming from the master BMS already here in Home Assistant as well. You can see the total cell voltage difference. Yeah, this is across all the connected PACs, 28 millivolt. The maximum cell voltage across all your batteries connected, 3.291 volts. Total current, total energy charged, discharged, all the information, total voltage, state of health, state of charge, remaining capacity, everything is here. 201 entities. And all these information are getting updated every 10 seconds now, as we have said it. The Gobel Power Monitor app, and have a look in the log file here. It is still on debug. So you can see here PAC 01, PAC 02, yeah? Putting all this information on the network, and Home Assistant is using MQTT to read all the information then. It is insane how much information you're getting. Let's see if we can connect 2 of the older Gobel Power BMSs as well. Alright, I've now connected another 2. Here you can see it already, 1, 2, 3 and 4. So all 4 BMSs are now connected here to this add-on. And let's go back into MQTT and have a look. So we can see here now the Gobel Power Monitor add-on with 367 entities. That is a long list, updated every 10 seconds. PAC number 1. Let me scroll further down. A lot more. PAC number 2. A lot more. PAC number 3. And even further down, it gives you PAC number 4 as well, of course. So all the information of every single battery through one device. And if you go all the way down again, you can see here the total voltage, the total whatever. It also tells you total PACs connected, 4 BMS, 4 batteries in parallel now. We've got a total full capacity of 620.5 ampere hours. Yeah, aggregated state of charge is now 47.3% across all these batteries. It reads all the information. So because the master shows how many battery packs are connected in Home Assistant, you can also do the automation I've shown you in one of the previous videos, where it actually checks of how many BMSs are connected. And if one gets disconnected, or the cable is faulty, or one is stale and doesn't respond anymore on RS485, the master BMS will then show only 3 packs. And you can set up an automation where it checks for that and sends you an alarm once one BMS has dropped out. So now you can really build your own dashboard and pick and choose whatever information you want. It is all here, and it monitors every single cell in all of your batteries now. And Home Assistant keeps a history of it. And up here for PAC number 4, for example, it tells you your cell number 1 is the one with the highest voltage, and cell number 16 is the one with the lowest voltage in your PAC. And if PAC number 4, cell number 16 is always the highest, there might be something wrong with it. So you can very precisely monitor all the cells in all of your batteries. And this is like 4, 16, 32. These are 64 cells now we can monitor here in Home Assistant already, yeah, with 4 batteries in parallel. Wow. And you can see how easy this setup is. You get this battery monitoring kit from Gobel Power with a server, piece of cable and the adapter cable. Configure this to your network with the VCOM software. Download the Gobel Power Home Assistant integration, configure it, enter the IP address you have assigned to this gateway, and that's pretty much it. You can also see the information here are read-only. Yeah, there's no switch, there's no setting you can change in the BMS, nothing. It is a read-only setup, and this is exactly very, very good. I would not recommend using any integrations in Home Assistant or any other application which can tap into your BMS and change settings or turn charging, discharging off or whatever, because the BMS is your safety device of your battery, of your whole system, and you don't want to have anyone, anything having access to this device. So 368 entities here read-only. And that's exactly the reason why it is okay to use an RS232 to Wi-Fi gateway. Because the Wi-Fi could drop out, it could be a bit hit or miss, a bit flaky. So, and even if it drops out, yeah, it is a read-only setup. The data doesn't come into Home Assistant anymore, but the BMS, of course, is still working, monitoring and reacting to any fault of your battery. But if you want a really safe and stable connection, use the RS232 to Ethernet gateway, and you can plug this one directly into your network. So my friends, there you go. This is the opportunity for you to get all your PACE BMSs with all details down to the cell level into Home Assistant, monitor everything, create a history, set up your own automations with alarms, notifications. And as you can see, it works with the brand new Gobel Power BMS as well with older BMSs I have. As long as all the PACE BMSs work together, you can get these information into Home Assistant very easily with this, what is it called? Serial Device Server Modbus Gateway RS232 to Ethernet. A lot of information. Okay, let me change this whole setup here from the PACE BMS to a JK-BMS, and I'll show you how this works. Because we cannot use this RS232 gateway anymore. Even the JK-BMS has an RS232 port. So we have to use RS485. So let me change the whole setup here, and I'll be back tomorrow morning and show you how this works. Good afternoon, my friends. Welcome back to the channel here. It is now the next day, which is absolutely pointless to even mention. Alright, I have now swapped the JK-BMS. No, I've now swapped the PACE BMS with the JK-BMS, this way around. I connected everything back to the test battery here. And obviously we need to connect this now to the network somehow. Unfortunately, we cannot use the Waveshare RS232 to Ethernet server or gateway anymore, because, well, the RS232 protocol of the JK inverter BMS does not match the protocol of the PACE BMS. So even if I plug this in here, it will not work. So we have to replace the RS232 to Ethernet gateway with an RS485 to Ethernet gateway. It's just a different device, but apart from that, the exact same process. And what I have here is this bad boy here. This is a Waveshare 8-channel RS485 to PoE Ethernet, so we don't need any power supply, any extra power supply. It plugs into a PoE port, which I have right here. And as soon as I plug this in, you will see it fires up. There we go. It gets power from the network. And then we have 8 channels of RS485 ports. And I've just connected a random one, port number 6 here, and we are going to plug this one into the RS485 port of the JK inverter BMS, of course. Bang. And they're making these Modbus gateways here, 1 channel, 2 channel, 4 channel, and this 8 channel device. So why would you buy such a gateway with more channels? Well, if you have more than a couple of batteries, you probably want to organize them in groups, and each group can connect to one of these channels. So obviously a maximum of 15 batteries per channel times 8 makes a lot of batteries. And then these devices provide all the data of each individual BMS on the network. And here with this RS485 Modbus gateway, we do exactly the same as we have done before with the RS232 gateway. We use the Wircom software again, start this one up, click on device, and it finds our 8 channels of the RS485 to Ethernet server. Yeah, and you open a random channel and you configure it the same way. You give it an IP address out of your range, a random port, whatever you like. So let's give this one here the 15,000, for example. The work mode is still TCP server. The network mask needs to fit your network, and the baud rate for the JK inverter BMS is always 115/200. So nothing else needs to be changed in here, and we can rename this one here to the JK-BMS. So the channel is called JK-BMS. Doesn't really matter. At the end, you just do a restart device. Takes only a few seconds to restart. So you can see here the JK-BMS with the internal IP address. If we type this into a browser, 03, password, and we are now logged into the 8-channel RS485 to Ethernet server gateway, Modbus server gateway. And of course you can change the settings here as well. You don't need the Vircom software anymore, but either way is super simple and totally fine. All right, log out. Let's go back to Home Assistant, go to Settings, go to Apps. We go into the Gobel Power monitor. We stop this one here for a moment. Let's have a look in the log file. Does it say anything? Successful stopped. It says BMS error, sending data, host unreachable, because it is still trying to connect with the 10002, which was our RS232 gateway. Yeah, so you need to go in configuration. We don't need to change anything for the MQTT connection to your Home Assistant. We probably want to call this one here JK-BMS, and the manufacturer is G-Kong. Device name JK. Let's do it this way, it doesn't really matter. We still got an Ethernet connection, but we are now using RS485 instead of RS232, and we have the JK-BMS. And the address has now changed to number 3, and we have also changed the port to 15,123,15,000. BMS baud rate, okay, 10 seconds interval of polling. Debug, doesn't matter. Save. And that's pretty much it. So now we have changed the configuration from the RS232 to the RS485 and the JK inverter BMS. So we go back to info, we click on start, we have a look in the log file and see what we can see. And we can see we get lots of errors and waiting and debug and errors and everything, so it doesn't work. Why doesn't it work? Because we haven't set the dip switches correctly. This setup obviously only works if you have a master BMS, yeah? And this one sits on dip switch 1000, so this is the first slave actually. And the slave BMS, they don't send any data via RS485 to other BMSs or to the host computer. You always need to have a master which is actually triggering the slaves to give them their data. So the only thing we need to do is we need to make this one the master, and we can immediately see the blue light is coming on. So there is a data transfer. This is the link which is established, and this is the data transfer to the app. And we can already see here in the app lots of data is coming in all of a sudden. Yeah, we've got cell voltages, we've got everything. Yeah, pretty much everything as we did before with the PACE BMS. So we go back here, apps, we go to devices and service. We have a look in MQTT, what we can see. We still got the Gobel Power monitor in here, but this is obviously now stale because the PACE BMS is not connected anymore. But we also have a JK BMS here and a JK PAC 01. So we've got two JK BMSs pretty much here now. So this JK device here has only 13 entities, yeah? And this is basically the master which has the total information of all the connected parallel BMSs. So when you have a look, see it's all total cell voltage, total current, total everything, total voltage, total state of charge. This is the aggregated data of all your parallel batteries. And then you've got the separate device for each of your packs. Yeah, this is pack 01. Why is it pack 01? It should be pack 00 actually. So on here we have all the details of this one single BMS now. All the settings are in here, 16 cells, cell overvoltage protection 3.65 volts, cell overvoltage recovery, cell undervoltage 258, and so on and so on and so on. And further down we also have, of course, the cell voltages. Here they come. Pack 01 view cell voltage, cell number 1, 3.258 volts, whatever. Yeah. So all the information, 5 NTCs, 0 kilowatt going in. So all the information is here again for this one JK inverter BMS. So you can see it's a bit different here from the PACE BMS, where everything was in one device basically. You got 368 entities for this one device with all the parallel batteries all included. And here with the JK, it's a bit different. You've got one JK master, which only gives you the total values, parameters, and then you've got one separate device for each of the BMSs. And this is something I asked them to do because I didn't want to have 368 or even more, 500, 600, 700 entities in one device. It is very hard to find stuff and to scroll up and down. And so I've asked them if they can change the software so it actually publishes one BMS as one device, and then you have the master as well. But unfortunately, something went a bit wrong here because the JK PAC 01 should actually be JK PAC 00. Yeah, it should have the same number as the dip switches have. So dip switch 4 is PAC number 5. Dip switch 7 is PAC number 8. So that's not ideal, but they will get it right at some stage. All right, let's connect another couple of BMSs. Got the extension cable, the LAN cable here, and we plug this one into the RS485 socket here as well of the master. And let's see what happens. Here we go. JK PAC 02, 03, 04, 05. So you can see each of the BMSs connected are getting their own device now in MQTT, and it's very easy to find and pinpoint entities now. 139 entities per battery we are getting. So this is the master, slave 1, slave 2, slave 3, slave 4. But 5 batteries all in total. And it kind of makes sense as well. So here PAC number 5, all the data, all the information. Isn't that crazy? You can even see the wire resistance for cell number 9 for PAC number 5 here in Home Assistant now. And if we have a look in the app's Gobel Power battery monitor, you can see the app hasn't got any CPU usage or RAM usage. There's no additional extra load on your Home Assistant device. Even there's so much data coming in. The amount of data is crazy with only 5 batteries connected, yeah? Yeah, the JK works a bit differently. It doesn't, you can see here PAC ID 2340 is the master, 12340. So 5 BMSs make sense. It goes via PAC ID here. And then you got everything coming in. So much data, unbelievable. Yeah, and basically now you are super flexible because you've got all the data in the world about your batteries down to the cell level, yeah? Down to every single temperature sensor. And you can do all kind of automations. You can check for high currents, high temperatures for each of your BMSs. You can set alarms, which gets you notified on your mobile phone through Home Assistant. You can create your own dashboards as well and show all the information about the PACE BMS or the JK inverter BMS, including all the settings you have set in both BMS. Yeah, and as I said at the beginning, a further flexibility is you don't have to plug anything into your BMS and connect this to Home Assistant. This is now completely decoupled because we are using the existing network in your house now to submit the data from the BMS into Home Assistant. We are using these Waveshare Gateways, these Modbus gateways, either via network cable, PoE possibility, or Wi-Fi. All right, my friends, as always, I link all the information down below. I've got heaps of links for these Waveshare Gateways on my website as well. You can buy them for like 15, 16 euros or US dollars on AliExpress. Or for a few dollars more, you get the whole kit from Gobel Power as well. The RS232 for the PACE BMS with the cables, the connectors, and also a power supply which connects directly to your battery then. Possibilities are endless. And you've got a really good manual, very detailed on the Gobel Power website, which is linked down below as well. So there's basically no excuse anymore to not have your PACE or JK inverter BMSs in Home Assistant. And this solution really doesn't break the bank. My friends, thank you very much for your amazing support here on the channel, for these wonderful and beautiful, yes, they are a bit more beautiful than everyone else, who are donating to the channel here, becoming a channel member. Also, thank you very much for all your comments under the videos. If you enjoy this sort of content, leave me a like. If you are new here, subscribe, it is free. We are on the road to 123,001 subscribers. I just haven't had the right number, so... Guys, thank you very much again, and we will see us again in one of the next videos when we do something potentially different. Until then, guys, you stay charged, stay safe, and thanks again for watching. See you then. Bye bye.